Hi, this is Mr. Singh here. Today we're looking at the solar system, which is part of the AQA Physics Syllabus Topic 8. But before we do that, have a go at these, pause the video, have a go at these 5 retrieval questions. Okay, let's see how you got on. So number 1, what is a nebula? It's a cloud of dust and gas. Number 2, what is a stable star and how it is stable? There you go. A star is stable because the forces in it are balanced. The outward pressure from the expanding hot gases is balanced by the force of stars' gravity. Number 3, why can't our sun make heavy elements? Higher temperature and pressures are needed for further fusion. One's found in a supernova. Number 4, what is a red giant? Red giant is a giant star that has the mass of about 1/2 to 10 times as much as our sun. Red giants get their name because they appear to be coloured red and they are very large. They form when hydrogen gas starts to run out. And number 5, how is a black hole formed? And there you go. It's when a supermassive star collapses. Okay, moving on. So, we are looking at the solar system and that's our learning outcome. You can see what our solar system is made up of. The key words are there: orbit, gravity, solar system, planets, velocity and acceleration. So what is our solar system? Well, our solar system contains one star, which we call the sun. The rest is made up of objects that orbit the sun. That'll be planets, comets. An orbit is the path in which one object moves around another one, and gravity provides a force which keeps an object within this orbit. The sun is orbited by planets, dwarf planets, satellites, natural and man-made. We have a natural satellite. The Earth has a natural satellite called the Earth, and our solar system is a tiny part of a galaxy called the Milky Way, and you can see that. Now, you need to know about the circular motion in orbit. If an object is travelling in a circle, it is constantly changing direction. Now, this means it is constantly accelerating. This means that it is constantly changing velocity. Now, for an object to accelerate, there must be a force acting on it. This force is directed towards the centre of the circle. In the solar system, the force that is acting towards the centre of the circle is a gravitational force between the planet and the sun. Now, an orbit is a balance between the force providing the acceleration and the forward motion, which is called instantaneous velocity of the object. The object keeps accelerating towards what it's orbiting, but instantaneous velocity, which is at right angle to the acceleration and to the force of gravity, keeps it travelling in a circle. And this diagram shows that. Okay, moving on. Orbital speed and radius. Now, the size of an orbit depends on the object's speed. The closer you get to the star or planet, the stronger the gravitational force. Now, the stronger the force, the faster the orbiting object needs to travel to remain in that orbit. If the object moves faster, the radius of its orbit must be smaller. If it moves slower, then the radius must be larger. You can watch this video, and this explains orbital velocity. Pause the video here and watch this video. Moving on. Here's some questions for you. Have a go at these 3 questions. Okay, let's have a look. There you go. State what is meant by a natural satellite and give one example. Number 2, state the force which keeps objects in orbit around the sun. And then number 3, in what direction does the force that keeps the Earth orbiting the sun act on Earth? If the Earth moved towards the sun, what would happen to the speed of its orbit, provided it were to remain in a stable orbit, and why? Well, the speed would increase as a greater force is acting, so a greater speed is needed to keep the Earth in a stable orbit. Here's a question. A satellite is in a circular orbit around the Earth. Figure 1 shows the velocity of the satellite at 2 different positions. Explain why the velocity of the satellite changes as it orbits the Earth for 3 marks. Okay, let's have a look. There you go. Gravity causes the satellite to accelerate. The accelerate causes a change in direction, and velocity changes because direction changes. Here's another one. Pause the video here and have a go at these. Okay, let's follow. A for 1 mark. What provides a centripetal force on the satellite? Gravitational attraction. And B, state 2 factors that determine the size. The mass of the satellite, the speed or the velocity of the satellite, and the radius. So you pick any 2 out of the 3 there. And that ends our lesson on the solar system.